Up. So introduction to Motorola. So we've about a 100-year-old company, started in 1928 with the first radio sold into public safety in about 1930. We've always been involved in radio, in communications, radio, cell, and more. In 2011, Motorola split into two companies, Motorola Solutions and Motorola Mobility. Motorola Mobility got the cell phone, so we don't have any part in that. We have a part in the two-way radios, in 911 call handling. In fact, we're dominant in both of those industries. And a local angle is that in the second quarter, we were awarded a $26 million contract with the state of Utah for next generation 911. So very active here locally. We're taking two-way radio in a convergent direction, merging two-way radio with LTE. That enables a lot of new workflows for two-way radios, such as device and fleet configuration and management. Organizations will have a fleet of these two-way radios, telemetry and analytics, offer enablement, things like that. And we even have a game-changing voice assistant we call Vicky. So, for example, public safety folks can run queries. For example, a policeman can run a license plate just by talking to the voice assistant. We've expanded into the computer-aided dispatch and command and control area, or in the command center software space, which is a big part of that is computer-aided dispatch. So getting officers and medics and fire trucks out to where they need to be. And we're moving all this technology from on-prem to the cloud. And as a result, in the on-prem world, agencies had complete control over their systems and were able to deliver high availability. As we move this technology to the cloud, you've got less control over when your VMs go up or down, and the networking between distributed systems. And these systems need high availability that having control gave them, so 4 and 5 nines of availability. So these are super demanding workflows to move to the cloud. Motorola has been a super exciting company to work for, as they've realized at the very highest levels that in order to be successful with a fully modern cloud native and DevOps approach, in order to be successful in this industry, they have to have a fully modern cloud native and DevOps approach. So these are the customers we serve. It's not just public safety and first responders. It's also hardened enterprise and commercial environments. And the 911, the two-way radios, theme parks, Disney, for example, anywhere you see where you have a lot of employees who need to communicate, you'll see Motorola radios. Now, the problem that I want to talk to you about today is as we expand internationally, we need to be able to operate our systems across international boundaries. And we've got engineers all over the globe, but they need to be able to operate in each geographic region. And as it turns out, the public safety domain areas, the public safety customers that we have, their data is governed by extra rules, more, above and beyond the normal GDPR, privacy, PII privacy kinds of rules that our regular software is subject to. We need to adhere to criminal justice information rules. So, for example, if we're operating in the UK policing has rules that only UK citizens can see the data, only UK citizens can operate that software. And so it poses a challenge to operate that software with a DevOps mentality, an own and operate mentality from the States or from Europe or from wherever we have our engineers. So we call it sovereign operations or SovOps. And so SovOps is when an engineering team owns the operations of a system, but may neither control the system nor see the data in it. And that's what we're up against. So I'll give you a diagram. So the problem with that, as I mentioned, is the second way of DevOps. If you remember the first, the third, the second way of DevOps, second way of DevOps is you want to strengthen your feedback loops. You want teams to own and operate their software. When the pager goes off, the engineer who wrote the software gets the page. He feels that pain. He has to fix it and make sure that it never happens again. So here's a diagram that illustrates the problem. Up above, we've got the functional requirements. We want to own and operate the software. We need to be able to deploy it, monitor it, troubleshoot it, investigate situations. Maybe there's a security breach of some kind. We need to get in there, poke around, and investigate it. We need to be able to do all these things. The engineers who wrote the software need to be able to do that. But they need to balance that with the requirements of the region where they're operating. Data sovereignty is the idea that uh, the country where the software is running, the data that's in that system, they want to fully own that data, have it reside in their country, and they only want people who are citizens and who have the proper clearances getting access to that data. So, with my example with the UK, there's no reason that that data should flow into the US, be viewed in the US, even though the engineer who's operating the system might be there. And the same thing about operations. They want the system to be operated by the sovereign citizens. Non-functional requirements, as I mentioned, are DevOps principles. We want to maintain the feedback loops, and we also want to preserve fast flow. This is the first way of DevOps from that series of books. Fast flow is the idea that a Scrum team, for example, has got everybody on it needed to solve, to address the issues with the software they're delivering, security, testing, engineering, compliance. They don't need to submit tickets to any other team. They've got everybody on that team fully vertically integrated to solve problems. So part of that is operations. We want the team to be able to operate their own software as well. So I'll give you a couple. We've been through a number of different ways to solve this problem. We'll show you which ones we rejected, and of course, we'll land on the one that we're working on. So, an anti-pattern is, a way that we don't think will work is to throw it over the wall. Treat it like in the on-prem days when, you shipped your software and you had a team install it and operate it on premises in a data center at the customer site. And so, we've got engineering teams developing software. The value stream ends with them. They throw the software over the wall. We could have, in the UK example, we could have a team in the UK operate it and keep it running, and there you go. They can see the data, they can operate it, but you don't get all the value that the cloud has to offer. For example, you don't get experimentation, regular experiments, A/B tests, that kind of thing. The development team can't do that with their UK base anyway. You get no incremental deployments. Similarly, you're kind of constrained to large batch sizes, which is an anti-pattern. Modern DevOps principles say you want small batch sizes regularly deployed, and that's the best way to be excellent in cloud delivery. And again, you don't have the feedback loop. If these individual teams, this is Germany and this is the US, of course, these individual teams are operating the software, they're very likely not feeding back everything about their experience to the original engineers. So we want everything. We don't want to lose anything with regard to modern cloud native software delivery. So another scenario, this might be the dream scenario if it would work for you. So got an engineering team, it's distributed around the world. They can't see data in these different regions. But what if your product was big enough that you could afford, or you were lucky enough to have engineers all over the globe uh, who could be part of the value stream team. So I've used this phrase, value stream team, several times. So a value stream team is an original engineering team who are, working hard to solve the problem of their domain area and deliver a constant stream of value into that domain area. Um, so, for example, we have our community engagement team, which develops a product that can get tips from the public, anywhere from, suspected criminal activity to a pothole in the road that's causing a safety concern. So that team is a value stream team, constantly improving that product, and they are charged with understanding that problem that they're solving and the customers that they're dealing with, and the community and the use cases. That's their focus. And so when I talk about value stream, that's what I'm talking about. Is they're mainly working on uh, solving use cases for the system that they're delivering. So maybe your sovereign operations teams are part of that value stream, and they're working alongside, even though it's across many time zones, they're working alongside to understand customers and deliver value constantly. And at the same time, they're owning and operating the solution. Well, at Motorola, we've got, I don't know, 75 different value streams that will all be shipping into these international regions over the course of time, and not all of them are big enough that they're going to be able to justify that. And so we need a solution that is efficient in that regard as well. So here's the idea that we're working on. So got your value stream team distributed worldwide. These folks probably can't see the data and operate the system unless they happen to be located in the region where the software is operating. Then you've got your sovereign operations teams in the different regions. These are physical boots on ground with the right clearances. These folks act as eyes and hands, act as escorts in the case of an emergency, some kind of outage, some kind of operational situation that needs to be attended to. And I've got them ranked in degrees of goodness here. So what we've learned is that the closest this team is to, being under the hierarchy of your company as the original dev team, the easier it is going to be for you. The less siloed it's going to be. These folks are going to communicate more easily. Under a common VP, that's good too. Not as good as if it's under a common director. You know, Eventually it could be any capable engineers, and you can make all of these work just fine. It's more ideal the closer they are to the original engineering team. And the key here is that we've got this enabling team called out to help facilitate this, to make the introductions, to ensure that this sovereign operations function works well with the original engineering function. And based on the title of my talk, you might have guessed at what this enabling team is. This enabling team we see as being an SRE team, a site reliability engineering team. And that means a lot of different things to a lot of different people. So I'm going to explain what that has come to mean for us at Motorola and why it works and why you might need it if this is a problem that you have. So what is SRE? Why, what is it? What isn't it? Do you need it? Do you already have it? Have you had trouble fully adopting it to it and sticking to it? Because there's some pitfalls there. I'm going to give you some patterns of how it exists at Motorola with some specific examples of teams that we've got and how we put it into practice. So site reliability engineering, the reliability engineering phrase has existed long before distributed computing came to an existence, or computing for that matter. And then the site on the front of that is reflective of the computing aspect of this reliability engineering. Now, everybody, if you've heard this phrase before, you've probably heard this definition. It's what happens when you ask a software engineer to design an operations function. This was the way that Ben Traynor Sloss, a VP at Google, described it. He's probably the first one to have had a site reliability engineering team. It hasn't. This definition hasn't served us very well. It's a little bit of an indirect definition, and the problem with it for me is that the use of the phrase operations. So SRE isn't operations. If this is all you know about SRE, um, it's it distracts you because we really want our teams to own and operate their own software. We don't want a separate operations team. To have a separate operations team means that our feedback loops are going to be interrupted. We want that value stream team to own and holistically operate their solution in the cloud. So if this isn't it, what is SRE? Well, hang on, I've got one more thing it isn't. Uh, SRE isn't automating toil. So this is another common thing that you hear when people talk about when they're first exploring SRE. It's 50%. SRE engineers should be spending 50% of their time doing toil and 50% of their time automating toil away. And so this associates SRE with toil, which they're involved in it, but if this is all you know about SRE, it's not a good definition. And the reason behind this is, what toil are we talking about? The toil we're talking about is toil that the value stream team incurred, either from, a couple examples, maybe a weak definition of done. They were pushing fast to get to market. They sacrificed the definition of done and incurred some kind of toil that needs to be done every time a new customer comes on board, for example. Maybe they got unexpected scaling, which is a great thing to have, but their architecture didn't plan for it, and they need to make configuration changes periodically to handle this unexpected scaling. So these are the kinds of toil that need to be addressed. And you don't want to bring on SRE just to automate toil. It's not going to be a rewarding job. These engineers cost a lot of money. And if this is the idea you have for them, it's not going to be very rewarding. So, what is SRE? So SRE is a partner to a value stream team. So the SRE isn't brought in to do the grunt work of answering the pages or to handle the tickets or to do the toil. They do work together with the value stream team to answer the pages and make them fewer and to measure the tickets, maybe understand the categories behind the tickets to prioritize which categories to do first and to handle the tickets and automate them away. They come on board to help the value stream team scale. So maybe like in the community engagement team, the tips example I gave, that value stream team works really hard to know its market. Maybe it's never scaled a cloud solution to the degree that they need to in order to meet the need. The SRE can help them do it. So to drive the point home, I've got a diagram here. This is the architecture of our location services software. So, when there are first responders out in the field, this is the architecture that gets off the radio their location and feeds it back into our systems. And I've blurred it so that we're not, this team didn't give me permission to show you this in detail, but I've blurred it and it's complicated, right? So an SRE engineer at Motorola isn't just going to come in here and start submitting pull requests on this technology uninvited, right? they come on to the, if location services needs help with this, um, yes, an SRE engineer will join the team as a partner to uh, establish with services exactly what problems they need to solve that an SRE can help with, and they'll partner with them to solve those problems. Maybe it's high availability, maybe it's scaling that we talked about, variety of different things that I'll get into in a minute. I think of SRE, another, an analog that I see, machine learning, for example. If you're a team that decides you need machine learning in your application, um, you're not going to go to first principles and start uh, implementing machine learning on your own. You're going to try and find a partner who understands it, bring them on board. They'll show you what platforms to use to add that to your uh, solution. So just reminded now after our hiccup at the beginning, if you've got comments or questions, comment in the platform that you're using, Facebook or LinkedIn or whatever, and we will get to those at the end or even after the presentation if you've got some comments. So, what is SRE? SRE is a partner enabling value stream teams to succeed in the cloud world. That's our definition of SRE. And so the different aspects, I've hinted at a bunch of different aspects of SRE that they can help with, that they can partner with value stream teams. The top row here, I'll go into detail on the top row. We'll skip the bottom row for now. But I've mentioned all these during the course of this talk, or most of them anyway. Resiliency is the idea of, software that recovers from errors, recovers smoothly from errors. You want resiliency in your cloud applications. And so VMs can go down, networks can go down. You want your software to be resilient in the face of those kinds of problems. You want your software to be available, meaning, the number of requests against your service, you want to maximize the number of good requests, and a 99.99%, returning good requests. That's availability. Enabling scale. Ideally you'd be setting up to do this automatically, where you can scale in and out to handle demand on your service. SRE can help with that. Observability. We're using the Elastic Stack for this task. This is the idea of being able to see what your distributed system is doing. Distributed systems are inherently, it's difficult to know how well they're working or not working because they're distributed. They're using PaaS services and Kubernetes containers, and potentially hundreds of different services interacting with one another. It's difficult to know how they work, and so observability is an entire um, area that you need to be skilled at as an SRE. And then finally, facilitating compliance. This is the whole topic of the talk, right? How do we operate within compliance of the region where we're operating? Yeah. Now, why is all this stuff important? Now, this wasn't covered. This kind of stuff wasn't covered when I went to school, and I recently looked at the class list for the computer science department at the University of Utah, where I went, and it's still not covered. I mean, the idea here is that the cloud has disrupted software engineering and made all these different aspects important. And I have to wonder, um, are these things going to be baked into a computer science degree, or maybe site reliability engineering becomes its own engineering discipline at some point? I don't know. Something I ponder. Maybe it's like an architect and a structural engineer. Those two folks work together to get a building designed, a building that is not only functional and serves the user's requirements, but also is a building that's safe to inhabit. Just one analogy that seems to make sense that requires a couple of different disciplines. So, how does all this come back around to sovereign operations? Well, really, all the things in the top row. The bottom row is important too. I'm just not going to go into those. It's the top row that drives home the point, directly impacts sovereign operations. So, in particular, if you can do all of these things unattended, if you don't need somebody in the region because your software fixes itself when it falls down and it's always answering its requests, or most of the time anyway, with high numbers of nines, if it can seamlessly scale in and out. And I'm not saying these are easy. These are hard. We're working on this just to deliver cloud solutions into our own countries. But my point is, if you double down on SRE, uh, that's your best opportunity at operating at from afar cloud technology, and to be able to do it with minimal staff in that remote region. So I mentioned we have 75 different value streams. We're not going to be able to hire 75 different teams in each country to look after that software. So we've got to be efficient with our resource. So SRE is a partner enabling value stream teams to work toward no ops. So we've been using the phrase SovOps all this time. If you this no ops phrase, you'll find this if you Google it. Basically, it means we need to work to a place where we don't require operations, where the software is basically self-healing and scales in and out automatically, all those good things. Okay, so now I want to cover a few. That's my sovereign operations discussion and the way we're handling it at Motorola Solutions. I want to take a couple of minutes to go over some patterns of site reliability engineering that we have at Motorola Solutions that a few of these we kind of discovered and recognized, oh, that's site reliability engineering right there, but we weren't calling it that. So start off kind of simple. We've got a couple of different value streams here. The way I've drawn it is you can have a value stream team that's just a single Scrum team, maybe a couple Scrum teams. And the red folks are folks focused on site reliability engineering within these Scrum teams. So maybe they are folks who care a lot about CI/CD pipelines and are working constantly to reduce the cycle time because that they know that leads to excellence in cloud native software delivery. Or maybe one of these folks really likes metrics and dashboarding and likes to understand how well the software is behaving and the number of customers signing up and things like that. You'll find this in your organizations. These are SRE engineers. And maybe it's only a fraction of a person. It's still an SRE function within the value stream team. Or maybe you've got a whole Scrum team within a value stream group that's focused on site reliability engineering. This is interesting because there's a pitfall here. You can start to see some silos. If this team starts to be held responsible for site reliability engineering, they're gonna have to use influence to get the product owners to start putting some things on the backlog, prioritize what things that need to be done in the SRE area. And our experience in this is, again, you're a partner, and the product owner needs to value what you bring to the table. The product owner is going to be the one to decide what kinds of reliability is most important for their business at this particular point in time. And so, again, this team is going to have to use their influence. Um, One way they can influence decisions is provide a lot of data. So, feedback loops in the form of dashboards to let these other Scrum teams know how their software is behaving. That's a good way to use your influence to let the product owners know this is what we think uh, about your software. Good. Now, there's one other way that SRE can be made available to an organization. And at the beginning of the talk, I mentioned that I led an SRE team within an SRE team, and this is what I'm talking about. So at Motorola Solutions, we've got uh, it's called our Cloud Infrastructure Engineering Group that serves all of Motorola Solutions. And we have a bunch of platform teams, and this is a stylized diagram, but a bunch of platform services, and then a CRE team, which I'll describe on the next slide. All of these folks act as a combined SRE team for the rest of Motorola Solutions. So platform services are interesting. Uh, you probably know what the value of these are, but I'll just briefly remind you. So share of wallet is a huge benefit from having platform components delivered centrally. So if this is an identity management system, we have one such platform that our team delivers. That means that if a salesman uh, sells this solution to a customer, and these customers log in using the shared identity management solution, well, the salesman can then go back later and say, hey, by the way, you should try out this other this other product that we sell. You can log into it by virtue of the fact that we use all the same identity management across all of our solutions. Now, that's just one simple example of a platform that can cause uh, that it can enable a company to gain a larger share of wallet at a customer site. Other reason platforms are useful, um, development cost, right? So if you're not developing an identity management solution for every product that you sell, you're going to save on development cost, and then also operating efficiency. If you can operate that identity management solution just once and spread the cost out over a bunch of different products, you're going to save money month on month. So all these different structures are in place at Motorola. We can see all this happening, and I suspect that at many large companies that's the same. So a little bit more about CRE. This is another term that Google invented. It's customer reliability engineering. And what this is all about is training, consulting, promoting best practices on everything I've talked about. The platform components that the platform SRE team ships, maybe how to compute SLIs and SLOs, uh, cloud native architecture in general to enable all sorts of best practices in the cloud. So training, best practices, and then another aspect that my team gets involved in is coordination. So I mentioned the 75 value stream teams that have to coordinate. Increasingly these teams are interconnected. Their services call one another in the event of a consequential cascading outage. They're going to be on the bridge trying to restore service together. They need to be all speaking the same language. And so incident response is huge, contingency planning, coordination on that, and then implementing common feedback loops. So, how well teams perform during their incident response activities. We've implemented feedback loops and are in the process of implementing more that keep teams informed about how they're doing so they can do continuous improvement, which is the third way of DevOps as it happens. So a few examples, specific examples. So there was a talk a few weeks ago from Jonathan Akers and Ryan Dobson about DevOps at MSI, and they covered all the SRE activities that they're doing in their group, reducing cycle time, measurements, product measurements, um, and their SRE are their team. So this is an example of SRE engineers directly embedded. And then we have Cirrus that has created a separate Scrum team within the Cirrus product group. That's the case where I said you could start to have some siloing problems that you have to be aware of. And so they've got this multi-stage maturity plan of what they're going to do with that SRE team over the course of, possibly years. I'm not sure exactly how long this is going to transpire, but yeah, they just started on that. And then, as I mentioned, my own team, incident response behaviors and measurements and feedback loops, feeding back to teams about postmortems. Had they written them? Had they done the mitigations? Uh, you know, helping them understand, measure that stuff for them. We're working on a break the glass capability so that when our sovereign operations teams uh, overseas actually do need to gain access to an environment to troubleshoot in the event of an outage, that they can record the session and then make that available for audit, and that to meet compliance requirements of that region. And then also visibility. Do we have visibility of all those different 75 value streams in the event of a cascading outage? Can we know exactly what's broken and in what region it's broken, and who's on call and who's addressing those issues? So takeaways. So if you need to operate across boundaries, you may need to respect data and operational sovereignty. You are going to want to do this while at the same time ensuring a strong DevOps culture with fast flow and strong feedback loops. This DevOps stuff works, and it's what is going to make a company excellent in cloud native software delivery. You're going to need people in country one way or another. And so why not reduce the need that they spend a lot of time operating and double down on site reliability engineering? It encompasses a lot of efforts that you're having to do anyway, but it's going to enable you to operate your software from afar with resiliency and availability and scale and observability and compliance. All those things that I mentioned have an impact on sovereign operations. So you probably already have SRE in your organization. There's many forums. They're probably already partnering with your value stream teams, helping them get to the cloud, and helping them get to NoOps, the NoOps nirvana one day. So thank you for your attention. I want to thank Silicon Slopes for hosting this session, MSI Tech Talks in the Cloud. Scott Pappas will be delivering the next talk in this series, and how much it's all about high availability and disaster recovery. It's on November 17th. You've got my contact information here, my Gmail address and my LinkedIn contact information. I'd love to hear from you if you have been working on this problem and have got some insight and experiences. Love to hear about that with SRE or SovOps. And if please visit our webpage at motorolasolutions.com/careers if you would like to talk to us about opportunities at Motorola Solutions. So thank you. Turn it over for questions and answers.